Hi guys, so welcome to again to my channel. My name is Malasa, and today I'm gonna be show you the continuity parts of the tutorial part number 22, which will be focusing on the assigning of and the definition of the notional or the imperfection load of this 20-story building. So previously, I have already shown you the principles that we are going to follow while we are going to defining the imperfection load on this story building and other related reinforced concrete and steel structures. We have seen two methods, that is an automatic method and the manual method. Both of the methods that we are going to use while we will be assigning the imperfection or the notional load on high-rise building. So if you are a new member for this channel, don't forget subscribe my channel. So if you subscribe my channel, you will be getting a more relevant tutorials which were prepared with the reference to this theory story building. So if you are a member of this channel also, try to share all my videos to your friends so that your friends will be getting more relevant tutorials which have been already prepared with the reference to this story building. And if you want to get an immediate notification for the newly uploaded video, just you can press the bell icon. And also, if you have any questions and comments regarding to the designing of the reinforced and steel structure, so don't hesitate providing me comments in my comments box so that I will be answering your questions as much as possible within a short period of time. We'll continue the today's tutorial, which is tutorial part 23, which will be focusing on the assigning of the notional or the imperfection load on this 20-story building. So now let's start. So in order to start the assigning of the notional load for this high-rise building, we first we need to define the load pattern, which will be related with the gravity loads that we have already defined before. Because as we have already seen in the previous tutorial, that is the notional load, the notional load, the notional load or the imperfection load uh, will be defined as the notional load pattern. So first we need to define the notional load pattern, that is using ETABS 2016 as per the Ethiopian and the European building code of standard. So just to do this, we need to go to uh, the we need to go to the define menu, and here just load pattern. Here we have already the load pattern that we have defined before while defining of the load patterns. Here first we need to unlock the model. Then in order to save time, I have already defined the load pattern which are related with the notional load pattern. So here we have the notional load in X plus. So here this load pattern with reference to the dead load in X direction will be defined for the notional load. Here, as you see here, that is the notional load in X positive direction with reference to the dead load will be defined. That is this modify the load pattern. Here I have already defined the notional load, which will be related with the dead load in x positive direction, that is x positive direction. So here I need to select the dead load here, the dead load, one of the gravity load that will be related with the notional load. And here I need to define, or I need to just uh, define the load ratio, which is the maximum imperfection load ratio. That means, as we have already seen before, that is the notional load, the notional load, the notional load, the notional load equals to, that is 5 times the the factored vertical force. That means, suppose if we have a structure just like this, here we may have a story force, that is VE. So this story force has to be converted into the equivalent lateral force, just like this. Just like this. So this force, what we call, it is the equivalent horizontal lateral force. That is the equivalent horizontal force, which will account the imperfection problem of this structure at this level. So this will be equals to 5 times VD. And here we may have also another story here. That is, so the notional load 1, that is V1. And here we may have the notional load 2, notional load 2, which is equal to, that is phi 2, this is phi 1, with a reference to this story, and phi 2 with a reference to this story. And we may have VA, that is, this is D, that is VAD 2. That means the story force at this level. So the notional load will be equals to, that is phi 2 times VA 2. So VED is nothing but it is the story gravity forces at each specified level. So with reference to the dead load, so we need to define the phi value. That means phi should not be greater than or equal to, it should be great. So phi must be less or equal to 5% according to the Ethiopian building code of standard and the European building code of standard. So here this may be reduced to sub values while we are going to just calculate the actual phi value. In our structure, we have already defined before. I have already shown you the phi value. That means the fraction value of the notional load. That means just you can just we can see it here. I have already shown you before. That means we have already checked that the notional load is required in this 20-story building. That means considering the notional load it is mandatory. We have already seen before. So before we are going to apply the notional load, we have to be sure that is there a mandatory is it a mandatory to consider the national load or not? So we need to check first the necessity of considering the national load. But in this building, we have already checked that the considering the national load is it is mandatory. So that is why just I missed this portion because I have already discussed, we have already discussed before in the previous tutorial, that is in tutorial part number 22. Okay, so here we have the phi value. That means the phi value or in x and in y direction has to be determined. So here, if you see this one, here this value is it is the maximum value of phi that we are going to consider during the definition of the notional load. That means actually the actual phi value exceeds, that is 5%, but we need to take the maximum value of phi, which is 5%. That is why just I put here 0.05. And in this case, the phi value is, it is 0.00472. And the phi value decreases while we are going from the top to down of the story. Here, if you see, just the phi value is, it is decreasing. It is decreasing. So the maximum notional load will be applied at the base of, I mean at the top of the structure. Okay, so now let's come back to ETABS. So here I need to consider the maximum phi value, that is 0.05, and in which direction? That is in x direction. That is in x direction. So the notional load has to be applied in two directions. So the notional load will be applied in two directions. Notional load, it has to be applied in two directions. That is in x and in y direction. Here, so we can also split the x direction into two. That means in positive x direction and negative x direction. And in y direction also we can apply in positive y direction and in negative y direction. But the value of the notional load which will be applied in positive x direction is equals to the notional load which will be applied in negative x direction, because the notional load, that means HF, which equals to the phi value times VED. So VED is nothing but it depends on the masses. So the masses in x and in positive x and in negative x direction they are equal. So that is why the notional load in positive x direction and the notional load in negative x direction are equal in magnitude, but they are opposite in direction, and it is also similar in y direction. So that is why it is enough to define the positive x and the positive y direction. But for the sake of just a clarification, I will be applying the notional load in negative x and in negative y direction, and we will see also its effect. So here I can just define the notional load with reference to the dead load, that is 5%. In the first one is in positive x direction. So apply, okay. And when we come to also in positive y direction, so I need to define also the notional load with reference to the dead load in positive y direction here. So I can apply 5% for all the load patterns, because here, as I have already shown you, the maximum limit of phi is, it is 5%. So I can take the maximum limit, that is 5%, because it is impossible to take the different value of phi for every stories, because it has this is impossible to just to put the different value of phi. So I can use the maximum value of phi, that is 5% for all load patterns. So now click OK. So I have already defined the notional load with reference to the dead load both in x and in y direction, that is in positive x and positive y direction. So this is one of the gravity load that we have already applied in our structure, that is the dead load. And the second gravity load that we have already applied is, it is the live load. So when we come to the live load, similarly we can define the notional load with reference to the live load both in x and in y direction. So just we can see it, that is modified. The load pattern has to be the live load. So as we have already defined the live load of the floors, which is categorized under category B, which is office building. So for office building, just we can use the phi value, that is the livelihood reduction factor phi 2, which is 0.3. So because we are just defining the variable or the livelihood for seismic conditions, so during the application of the livelihood for the seismic condition, we need to use the livelihood reduction factor, that is phi 2. Okay, now here the load ratio is, it is 0.05, and here we need to apply first in positive y direction. So later I will also define for the positive x direction. So now click OK. And also the live load in x positive direction also, it has to be defined. Here I have to select the live load, here the live load for floor, and I need to put the 5% here, and I need to define the notional load with reference to the live load in positive x direction, that is x. Now select this one and click OK. And just here the live load is, it is the second gravity load, and when also we come to the live load here, this is the live load for floor, but the live load for vehicle also has to be also considered during the defining of the imperfection load. Here just modify, here this is the live load for vehicles, that is for the basement portion, because the basement portion is, it is the parking zone. So for the parking zone, we need to apply specifically the variable load or the live load which is associated with parking, that is the 5 kilonewton per meter where we have already applied this load. This load has to be reduced by 0.3 as per the Ethiopian Building Code of Standard and the European Building Code of Standard for seismic conditions. So we need to select this one. So we need to select this one, and here we need to apply the phi value, that is 0.05, and just select x positive direction first, and later I will also define for y positive direction. Okay, this one. And I need to also define the notional load with reference to the live load for vehicles in x positive direction. I mean in a y positive direction here. Just modify here. Now here the vehicle variable load or live load is selected here, then 5%. Then previously I have defined for x positive. Now I need to define for positive y direction. Click OK. So, and the what is left, the roof live load. Here the other gravity load that I have already assigned in this 20-story building is the live load for roof. So here the live load for roof must be assigned in a separate way. That is, we need to isolate it from the live load for floor, because here during the definition of the mass force, we need to use a different reduction factor for from live load and roof live load. So that is why just I have defined in a separate way for the live load associated with the roof. So now select the live load for roof here and 5% here, and I need to define first in positive x direction. Now click OK. And I need to define also in the other direction, that is in positive y direction, uh, for the live load for a roof. That means so the notional load in positive y direction associated with the gravity load, that is the live load for a roof, is just defined just like this, and click OK. And the other gravity load that we need to consider for the definition of the imperfection load is the wall load here, because we have applied the wall load to our structure. So here I need to select the wall load here, and I need to put the load ratio, that is 5%, and I need to define also this imperfection load with reference to the wall load in positive x direction. And now click OK. And just go down. So I need to also define the imperfection load in positive y direction with reference to the wall load. Okay, here I need to select the wall from the drop down list here, and I need to define the load ratio, that is 5%, and just select the positive y direction. So the wall load, the imperfection load with reference to the wall load is defined in positive x and in positive y direction. Okay, and the other gravity load that I have already applied in my structure is the water tanker load. So the imperfection load with reference to the water tanker load has to be defined in both x positive and y positive direction. So to do this, just I have already defined it, and you can simply define uh, just by following the procedure that I have already shown you. So here, this is the load pattern, that is the water tanker load. Here, I need to select the water tanker load from the drop-down list and just put the load ratio, the maximum imperfection load ratio, that is 5%, and just select first in positive x direction. Now click OK. And the other, I need to define in positive y direction. Here, I need to select the water tackle load and 5% here in positive y direction. Now click OK. So just go down, and the other gravity load that I have already applied in my structure is the waterproofing load. So the waterproofing load, the imperfection load associated with the waterproofing load has to be defined in positive x and positive y direction. Here first, I need to define in x positive direction. So we take care that the waterproofing load is selected from the drop down list here, and 5%. Now click OK. And in y positive direction also, the imperfection load associated with the waterproofing load in positive y direction has to be defined just like this. So, and what is left? The floor finishing load. And the other and the last gravity load that I have already defined and assigned in my structure is the waterproofing, I mean the floor finishing load. So the imperfection load associated with the floor finishing load in positive x direction and positive y direction has to be defined properly. Just modify it. And here, the superimposed floor finishing load must be selected from the drop-down list, and just put the maximum imperfection load ratio, that is 5%, and select the positive x direction. And also defined in similar way for positive y direction, just like this. Okay, now here all gravity load pattern with reference to the imperfection load is defined properly. So here I have defined the imperfection load both in x and y direction with reference to the gravity loads. So here now click OK. So here that means the imperfection load, that is the imperfection load for the dead load, for the live load, that means for floor, for the live load, for vehicle, the live load for roof, the dead load, the permanent load, that is the wall load, the water tanker load, the waterproofing load, and finally the floor finishing load. So the imperfection or the notional load has to be defined for all both gravity loads. That means the dead load for floor live load, for live load for vehicle, live load for roof, for wall load, for water tanker load, for waterproofing load, and finally for I mean floor finishing load. This is for both x positive and y positive direction. So I have applied for all load patterns in x positive and in y positive direction. Okay, so and now I need to also define for that is so I need to define load cases with reference to the notional load, because here all those load cases are placed in scattered way. So I need to collect all the imperfection loads that are applied in positive x direction. That is 1, 2, 3, 4, 5, 6, 7, 8. So 8 load cases in positive x direction. That is 8 load cases in positive x direction and 8 load pattern in y positive direction. So I need to collect all those load patterns which are assigned as the imperfection load in positive x direction as one load cases, and similarly also for y positive direction. So just to do this, so I need to go to the define menu and load cases. So here I can just simply click add new load cases. Here just I can write the name of the load cases and I can select all the load cases here just simply by adding. I can select all the imperfection load cases that are applied in positive x direction here, and that is the load in x positive direction, and also here the live load in x positive direction just like this. And in similar way we can collect all the imperfection loads that are applied in positive x direction as one load cases. So I have already defined these load cases in order to save time for this tutorial. Yeah, the notional load for gravity here, so we have two cases. That means notional load for gravity load is notional load for gravity and notional load for seismic. So here, during the definition of the notional load for gravity, I should not use the live load reduction factor, that is phi. That is, I should not use the live load reduction factor. So in the case of seismic load combinations, that means in the case of the definition of the notional load with reference to the seismic condition, I need to use the live load reduction, that is phi 2. So here, during the definition of the notional load, I have to be take care all these conditions. So first I need to define for gravity case, and later I will define for seismic case. So first, now let me define the notional load cases for gravity combination. Just that is modify. Here, the notional load that is in a specific direction with reference to the gravity load, that is in x positive direction. Here I have already collected all the notional loads that are applied in positive x direction here. that is the notional load in x positive direction, that is for dead load. For live load, x plus, uh, and also for notional for that is for floor finishing load, and also for the live load for roof. That is here, just we can see is here, this is the notional dead load for floor finishing in x positive direction. The notional load for live load for roof in x positive direction. The notional load for live load for vehicle in x positive direction. The notional load for dead load, that means wall load in x positive direction. So in similar way, we can collect all the notional loads that we have already defined in positive x direction in one load cases. And here we need to define also the scale factor. For dead load, that is for permanent load, the factor that we need to use is it is 1.35. This is for permanent load. For live load, that is for variable load, we need to use a factor that is 1.5. So that is why all the live loads or the variable load has to be multiplied with the factor of 1.5, and all the permanent load has to be multiplied with a factor of 1.35, because I need to I have to factor uh, the imperfection load while defining the load case. Okay, so here the notional load, that is the notional load for gravity load combination in x positive direction is it is defined just like this, and also the notional load for gravity in x negative direction will be defined later. But now let me also define the load, the notional load for gravity in y direction, that is in y positive direction. So just in similar way we can define it. Here just I have already defined for positive y direction. Here as you can see it here, that is the notional load for gravity in y positive direction. So in similar way I can collect all the imperfection load which are defined before in positive y direction in what load cases. Good. Just like this, and the factor is it is similar. So this is all about for the definition of the imperfection load cases in positive x direction and in positive y direction with reference to the gravity load combination. And when we come to also in the case of seismic load combination, here in the case of seismic load combination, we need to use the live load reduction factor, that is phi 2. Phi 2. So that is why we need to define it specifically for seismic case, because the imperfection load in x direction, that is the notional load in x positive direction for this seismic condition equals to the live load times the live load reduction factor, that is phi 2 times what? Phi bar. Here this is the in positive x direction. But in the case of gravity load combination, simply the notional load in x direction equals to, and here that is gamma times g plus gamma times q in what? In x positive direction. Here in this case, no need of just using the live load reduction factor, that is phi 2, So we should not use the live load reduction factor, but in this case we need to use the live load reduction factor because we are defining the imperfection load in respective direction with reference to the seismic condition. Okay, that is why just modified, and we can see it the notional load with reference to the dead load in positive y direction. So we need to multiply it with a scale factor that is 1.35 because it is a permanent load. And also when we come to the live load in y positive direction with reference to the building, that is floor live load, that is 1.5. And just like this I have already collected all load cases in one load cases. Just click okay. So this is for the seismic, I mean, sorry, here for seismic condition just modified. Here the notional load for the load in x positive direction because we are defining for the seismic condition. So the notional load, the imperfection load with reference to the dead load in x positive direction has to be defined just like this. Sorry, in the case of seismic combination, we should not use a factor of safety here because G plus Q times the live load reduction factor times phi. Here this is the notional load in x positive direction for seismic condition. But for gravity combination, that is we can use the combination factor. That is the live load, the load combination factor. That means gamma times n, the notional load in x direction. I mean gamma. Sorry, here we need to use gamma here, and we need to use gamma here. So every load pattern has to be multiplied with the combination factor, that is the partial safety factor 1.5 here, 1.35 here, and 1.5 here. But in this case, we should not use 1.35 and 1.5 as a combination factor because just as we remember, just we have said that for seismic load combination, that means for ultimate limit state, so the load is that is Q plus G plus here this is phi 2 plus G plus RZ cube in x direction. This is the combination of the loads for ultimate limit state. Okay, so here just come back to here the notional load for the load in x positive direction, just like this it is, we need to take 100%, that is 100% of the dead load. And for in the case of live load, we need to use phi 2 as a reduction factor, live load reduction factor, that is 0.30. Here, this is phi 2. And similarly, all the gravity loads will be multiplied with 1, and all the variable loads will be multiplied with 0.30, except okay. I think all the variable load will be multiplied with phi 2, that is 0.30, and all the gravity loads will be multiplied with 1. So we need to take 100% of the gravity load and 30% of the variable load. Now click OK. And also similarly in y direction we can define the load cases in similar way. So here we have defined 4 load cases, that means 2 for gravity load combination and 2 for seismic load combination. Now click OK. So next we need to define the notional load case in negative x and negative y direction. So to do this, I just go to the define menu and load combination. So here, that is, we have already defined y positive and for x positive direction. So what is left for y negative and x negative direction? So this is the opposite of x positive and this is the opposite of x negative, x positive direction. So here y negative, which is equal to negative 1 multiplied with, that is, x positive, and x sorry, this is y negative, y positive, and x negative, which is equal to minus 1 multiplied with x positive. So we can combine, or we can define the load, the imperfection load cases in y negative and x negative direction as a function of the imperfection load defined in y positive and x positive direction. So just to do this, we can add a new combo. So we can just select the here, just I can, now let me delete it. So here, this is in the imperfection load, that is the notional load in the notional load, the notional load case in x negative direction. So here, that is it is equals to the notional load. Here the notional load, where is it? Yes, the notional load in x positive direction for gravity case, and this is for gravity, for gravity for gravity combination. That is the notional load in x negative direction for, that is, the notional load in x negative direction for gravity load combination, which is equal to the notional load for gravity combination and x positive direction. So we need to multiply it by minus 1 because it is the opposite of x plus, here as I have already shown. That is x negative, which is equal to minus 1 times x positive direction. So here in this way, we can define the notional load case in negative x direction. So where is it? Just I have already defined it. Just okay, here, that is in x negative direction. That is the notional load for gravity in x negative direction. The notional load for gravity case in x negative direction, which is equal to the notional load for gravity combination in x positive direction, which is multiplied with the negative 1. So this is for negative direction. And similarly, the imperfection load cases in y negative direction with reference to the gravity load combination is defined here, and also the imperfection load cases for seismic combination with reference to the x x negative direction also defined here, and the notional load for seismic combination in negative y direction is also defined. So we have four load combinations in negative direction. Two is for gravity combination and two is for seismic combination. Now click OK. So uh, so we have already defined the load cases, and we have defined the load pattern for imperfection load, that is for notional load, for both x positive, x negative, y positive, and y negative direction. So what is left? Load combination. Load combination. So every imperfection load will be combined with the gravity load as well as for lateral load. That means here we have two type of combination, that is the gravity load combination for gravity and for lateral load combination. So for a gravity load combination, that means the permanent load plus the variable load plus the notional load in x direction or in x minus x direction or in y direction or in y minus direction. That is, we love for combinations we love for combination of notional load in the case of gravity combination. And we have the rest that is we can define also one extra combination, that is the gravity the permanent load plus the live load. And when we come to the lateral load combination, we'll have also similarly for we'll have also 8 combinations. 8 combination for the linear static case. That is 8 combination for linear static case and 8 combination for response spectral combination. So we'll see that one by one. Okay, now let me come back to ETABS. So go to the define menu and just the load combination here. Here I have one load combination, that is load combination G. Here that is 1.35 G. Okay, here 1.35 G. This is for gravity. That is for permanent load. So here that is permanent load for service. I have already this permanent load for service means the gravity load plus the variable load here. This is the summation of all gravity load and this is the summation of all variable loads. So here for service purpose we should not use live load reduction factor phi 2. Be take care here while defining the service load. For gravity combination, we should avoid using phi 2 or live load reduction factor. But in the case of seismic combination, we should use live load reduction factor phi 2. Okay. And we need to multiply this with 1.35 because here we are defining the load combination with reference to the gravity load is. Previously, we didn't factor this load. This is a service load. That is why just we are applying the scale factor, that is 1.35. Okay, this is one of the load combination, which is one of the load combination, this one. That is the dead load plus the live load. But this has to be factored. That is 1.5 or 1.35 dead load plus 1.5 live load. Okay, no, sorry. This is the second option. So the first combination, now let me write it. The first combination is, that is for gravity combination. For gravity combination, that is 1.35 permanent load. This is one. And the second one is 1.35 times the permanent load minus 1 times the notional load in x direction. And this is the notional load in x direction, that is in x negative direction. And the second one is 1.35 times that is the permanent load, minus 1 times the notional load, x positive direction. And the fourth one is 1.75 times the permanent load minus the notional load in y negative direction. And the other 1.35 times the permanent load plus 100% of the notional load in y positive direction. Here we have 5 combination for the permanent loads. And we'll have also the second combination. That means just now let me show you here this combination modifier. Here 1.35 the gravity load minus the notional load in x negative direction. So while I am combining those two loads, I need to use a scale factor here. That is -1 for the notional load for gravity combination in x positive direction with -1 in order to get the notional load in x negative direction. So the notional load in x, now let me zoom it. Here, the notional load in x negative direction equals to the notional load for gravity combination in x positive direction multiplied with -1. So that is why just I am using a scale factor -1 here. And the permanent load for service, as we have said, that is 1.35 because it is for permanent load. Okay. And similarly here, this is in similar way. So this and also here this one and this one. This is this. So now this one, this one, this one, and this one is for the notional load in the case of gravity, in the case of permanent load combination. This one, this combination. And when we come to the permanent load and the live load combination, here we'll have also 5 combination. That means 1 point. So here 1 point. That means just go to here 1.35 dead load plus 1.35 permanent load plus 1.5 variable load. This is one of the combination. And the second combination 1.35 the permanent load plus 1.5 the variable load plus the notional load in x positive direction. And the second one is 1.35 permanent load, the permanent load plus 1.5 the variable load minus the notional load in x negative direction. And the other 1.35 the permanent load plus 1.5 the variable load plus the notional load in y positive direction. And the other is 1.35 the permanent load plus 1.5 variable load minus the notional load in y negative direction. Y negative direction. So how many combinations are there in variable load and permanent load combination? Here we have 5 combination. Or what are those? Just now let me show you here. This is the notional load in x negative direction, and this is the notional load in y negative direction, and this is the notional load in x positive direction, and this one is the notional load in y positive direction. Now let me zoom it for clarification. Here, just here, this is 1.35 permanent load plus 1.5 variable load minus the notional load in x negative direction. The second one is 1.35 permanent load plus 1.5 variable load minus the notional load in y negative direction. And the other 1.35 the permanent load plus 1.5 the variable load plus the notional load in x positive direction. The other 1.35 variable load, permanent load plus 1.5 variable load plus notional load in y positive direction. And the other is this one. That is, we need to put one extra load combination excluding the notional load, because we will use this load combination while we will be excluding the notional load in all 4 directions. So that is why 1.35 permanent load plus 1.5 variable load combination is placed here, just like this. We will use 8 for the checking of the story forces, or we will use this for the determination of story forces. We will see it later. The story forces or gravity forces, while we will be determining whether the imperfection loads consideration is mandatory or not. So here we have so how many combinations are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we have that is 10 combination. And the third one here we'll have also another combination. That means the live load plus the permanent load plus this is for gravity combination, and the other is for seismic combination. All those are for gravity combinations. Those are for gravity combination. All those are gravity combination. That means excluding what? Live load reduction factor is not considered in the case of gravity load combinations. And in the case of seismic load combination, we will consider this live load reduction factor. So how to do this one? Simply, in the case of seismic load combination, we will not use this factor. That is 1.35 and 1.5 combination factor will not be used in the case of seismic combination. So the first load combination for seismic is the case of seismic. The permanent load plus phi 2, the live load plus the notional load in x positive direction. This is one of the combination. And the other, the permanent load plus phi 2 times, this is like the variable load. The variable load minus the notional load in x negative direction. And the third one, the permanent load plus phi 2 plus the notional load in y positive direction. The fourth one, the permanent load plus Phi2 times the live load, minus the notional load in y negative direction. And this is in the case of seismic. And this one is seismic. And this one is also seismic. And this one is in the case of seismic. So here, this one is in the case of, that is gravity. We have already discussed it. Gravity, and this one is gravity, and this one is gravity, and this one is gravity. And here, similarly, this one is gravity, and this one is gravity, and this one is gravity, and this one is gravity. So here, every combination has also two combination here. That means so now let's and here in the case of seismic there is one extra load here, that means RZ cube load. RZ cube, that means RZ cube in x positive and x negative direction. Here plus also RZ cube load in x positive and negative direction. And here we'll have also plus RZ cube load in x positive and negative direction. And similarly here we have RZ cube load in x positive and negative direction. So the direction of the imperfection load and the direction of seismic must be similar. If we are defining the notional load in x direction, so we need to consider the seismic load in x direction. And if we consider the notional load in y direction, we need to consider the seismic in y direction. So that is why this combination will this case will have two combination. And this will have two combination. This will have two combination. And this will have two combination. Totally, how many combination are there? 8 combination will be required for linear static condition. And for dynamic analysis, we'll have also 8 combination. So here we will see it one by one. So the first one is, just now go to here. Now let me zoom it. Here the load combination. That means EQX minus 0.3 EQY minus plus service load for seismic minus notional load. Here the notional load in x negative direction, because we are applying the notional along x negative direction. So the service load for seismic we have already defined it. Service load for seismic, meaning excluding that means considering what? Psi 2. So we need to consider psi 2 for the definition of the load cases, service load for seismic case. And here this is, this one, this is the RZ cube load. That is the RZ cube load, that is EQX in negative direction minus, that means 100% of the seismic load in x negative direction will be combined with 30% of the seismic load in negative y direction. Here this is one of the options. And here we need to take the governing direction. That means here 100% of the seismic load. Sorry, this is minus 1. Because we are applying in negative x direction. So here we have minus 1 here. So 100% of the seismic load is applied in negative x direction, and also 30% of the seismic load is applied in negative y direction. So here the governing direction is negative x direction. So that is why we are taking EQ negative, plus the service load for seismic minus the notional load in x negative direction here. This must be consistent with this one. This is the notional load in negative x direction must be combined with the earthquake load in negative x direction. So in similar way, we can combine for positive x direction, positive y direction, and negative y direction. And here, this one is that means EQY minus, meaning EQY minus, that means 30% of the seismic load is the 30% of the seismic load in negative y direction will be combined with 100% of the seismic load in negative x direction. And here, just the service load for seismic, this is, the combination, that means psi 2 q plus 100% of the gravity, the permanent load. So we need to use the scale factor 1. And the notional load for seismic combination, that means x plus, that means the notional load for seismic combination x plus, that means minus 1. Why? Because the notional load in negative x direction is equal to minus 1 multiplied with the notional load in x positive direction. We have defined it before. That is why we are multiplying it with negative 1. That means negative 1 multiplied with x plus will provide x minus the notional load in x direction. So this is one of the combination. And in similar way, we'll do just 8 combination for linear static cases. Just 8 combination for linear static cases just by changing for example, in this case it is negative x minus, and we'll have also negative x minus, that is minus, will be combined with, that is 0.3 EQ y plus, that is the service rule for seismic, which is this one. And here we are applying in negative x direction. So here minus the notional load in x negative direction, because here the negative x direction will have 2 combination for 30% of seismic load in y positive direction and 30% of seismic load in negative y direction. So every combination, every axis will have 2 notional loads. That means x plus, x minus, y plus, y minus. This will have 2 combination. 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 How many combinations are there? 8 combinations. So 8 combination for linear static case and 8 combination for response spectrum combinations also. Just like this. You can see it. Just modify, and the second option, that is the negative x, will be combined with positive here. Just like this. This is positive, as you see, and here minus notional load in x positive direction. And here we can the third one. You can see also the third one. Here in x positive direction, here also 100% of the seismic load in x positive direction will be combined with 30% of the seismic load in y negative direction plus the service load for seismic. This is uniform for all combination, plus the notional load in x positive direction. Meaning here this is the governing direction where the seismic load is applied. So, and this must be consistent with what? This one. And here that is positive, this is positive, and the second one is, the second combination may be EQ x, that means the earthquake load in positive x direction will be combined with what? 30% of the seismic load in y direction, that is y positive. Here, this must be what? This must be positive. So every direction will have two notional load combination. Totally, we'll have how many notional load combinations? 8 notional load combinations for every directions will be generated. Okay. Here this is for the notion. Here this is for the notional load combination. The load combination incorporating the notional load in a respective direction. In similar manner, we can define the load combinations of the gravity load, the variable load, and the notional load. Just modify it. Just we can see it. We can see one of the combination. Sorry. So this is the combination, one of the combination for the response spectrum analysis. So the notional load combination with reference to the response spectrum load cases is just like this. So now let me show you one of the combination. So it follows the procedure of the linear static load combinations. So here the 100% of the response spectrum loads in negative x direction will be combined with 30% of the response spectrum uh, loads in y negative direction and combined with the this load cases and combined with the notional load case in x negative direction because the governing one is this one. So here response spectrum x positive and x negatives are the same, and the response spectrum y negative and y positives are the same but opposites in direction. Okay, so just we can define it as the linear cases. That means response spectrum x negative will be equal to -1 multiplied with response spectrum x positive by using the load combination. Just we can use that method. Okay, here, but in this case they are the same, no difference at all. You can exclude x negative and y negative because they have the same magnitude but opposites in direction. So just go to the define menu once again, the load combination. So here we'll have 8 combination there. So here we'll have 8 response spectrum notional load combination with reference to the response spectrum. And here there is here this combination is for serviceability requirements. Here this this is the serviceability combination for uh, variable load with reference to the seismic case. And here this is the service load for deflection. So totally how many combinations are there? We'll have how many combinations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 16, that is 26. 26, 26, 27, and 28 combination. Totally we'll have how many combinations are there? 28 combinations. So 28 combination. 28 combinations. So now let's run the analysis using all those combinations. Just now run the analysis. So now ETABS 2016 is analyzing the Estonian story building using the defined respective load combinations involving the notional loads in every respective directions. So this is the automatic notional load analysis. In the case of manual notional load analysis, so we need to extract the story forces, and then uh, as a percentage of with the percentage of the story forces, we will define also the equivalent horizontal forces at every respective stories. So the determination of or the definition of the notional load in using a manual method is tedious, but in the case of automatic load combinations, just it is simple, and it is a precise consideration of notional load at every respective of load level. So now ETABS is now on the way of completing the analysis involving the notional load in every directions, both for linear static cases and response spectrum cases. So now it is completed now. The analysis is completed. So now let me see the effect of the notional load in a respective direction. Okay, here this is the the displacement. So now let me show you. Just now let me go to the effect of the notional load in. For example, if we take the first gravity load combination of the notional load, that means the notional load plus the gravity load combination. This one, that means G. For example, this one here, that is the notional load for gravity combination in x direction. In x direction, that means in x positive direction. And in x positive direction, yeah, in x positive direction. So we can use this scale factor, and if it doesn't show the displacement, we'll increase it. And in x positive direction, so now apply. So here, just that is in x positive direction. Just you can see it. This is in x positive direction. This is y positive direction, x positive direction. Okay, okay, because all those are the in positive direction. The negative directions are located in the load combination list. Here, this is sorry, this is in x positive direction. So now here, the structure is moving in this direction. That means here in this direction. That is x positive direction. This one. If the movement is along this direction. Just observe it. Now let me come back. Now let me come back. Just like this. Now here the notional load is applying in positive x direction. So the effect, the movement of the structure is along positive x direction, just like this. If you stop the animation, the structure will be deflected along the positive y direction. I mean along the positive x direction. Now let me stop it. Yeah, just like this. It stops. It goes and stops. And now animate it. Stop it. Yeah. So you can be sure that the structure will stop after moving into x positive direction. That means into this direction. Here, into this direction. So this is the effect of the notional load, which is applied along the positive x direction, and the notional load which is applied along in positive x direction will make the structure deflected to the positive x direction, as you are watching in animation. And when we come back to also the other direction here, now let me show you. This is in x positive direction. So, x positive direction, is it is perfect. So now x negative direction. So x negative direction can be obtained from the combination list. Just come to here. Now let me apply. So when I apply the 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 deformed shape, in which direction will be deflected it? That means in this direction, which is the opposite of this one, which is in this direction. So just observe it. Now let me apply it. Yeah, here. This, the structure is deflected along the negative x direction because the notional load is applied, the notional load is applied along the negative x direction. So this shows that the application of the the application of the notional load in a respective direction, that means in x positive and in x negative directions, are perfect. So x negative direction is okay. And when we come to also the positive y direction, that means just go to the deformation, and now let me come back to the load cases list because positive directions were defined in load cases lists. So here just to go down, that is y positive direction. So in the case of notional load, which is applied along the y direction, so we need to select the direction of the contour here. So the notional load which will be applied along the positive y direction will make the structure deflected. The structure deflects in this direction. So it moves in this direction because this is the positive y direction. So it moves in this direction. So now observe it. Apply. So now let me increase that is 500. Now apply. Yeah. Now let me increase also, it is 1000. I can make that is 750. Apply. Yeah. Now here the structure is moving along the positive direction because I am selecting the direction of the notional load in positive y direction. And also I come back to the combination list in order to select the negative y direction. So the negative y direction is this one. So now when I apply the deformation will be come to in this direction, that is in opposite direction, that is opposite of y, which is into this direction. Now observe it just like this, which is the opposite of the positive y direction. So this indicated that the magnitude of or the effect of notional load along the positive y direction equals to the magnitude of the effect of the notional load along the negative y direction. So they have the same in magnitude but opposite in direction. And similarly in x direction also the effect of the notional load will have the same magnitude but opposite in direction when we apply the notional load in x direction. So it is enough to consider only two directions. That means the x positive and y positive directions are adequate enough to check the effect of notional load in this story building. Okay, click. Okay, now close it. So this is, I think, all about the consideration of the notional load in this theory story building using ETABS 2016 as per the Ethiopian Building Code of Standard and the European Building Code of Standard. So next time I will try to show you the application of the notional load using the manual method. That means the notional load will be calculated manually and will be applied at the nodes of every uh, vertical members, so that we will see also its effects and we will compare the results with the result which is obtained by an automatic consideration of notional load. So this is all about for today's tutorial, which is the application of notional load in theory story building using ETABS 2016 as per the Ethiopian Building Code of Standard and European Building Code of Standard using an automatic method. So if you like this video, don't forget uh, sharing all my videos to your friends so that your friends will be getting more relevant tutorials which have been already prepared before with reference to this theory story building. So if you have questions regarding to the structural design of any reinforced concrete structure and steel structure, you are always welcome, and I will try to answer your questions as much as possible within a short period of time. So, if you want to receive a notification for the newly uploaded video, don't forget pressing the bell icon. So, this is all for today. See you next time with a very interesting topic, which is the consideration or the application of notional load using a manual method on every nodes of vertical members. So see you next time. Bye bye.